Hey, what's going on, guys? So another year has passed, and we have a brand new year to look forward to, and a new year for you to grow as a developer and learn more to get where you want to be in your career. So for those of you that are kind of new to this channel, this is something that I do every year. I've done it since 2017, and people seem to really like it. It's a complete map or guide to web development technologies and topics. So we talk about things like programming languages, frameworks, development tools, and much more. So I just want to mention that this is not a trends video like you see a lot of this time of year. I will talk about some recent trends like Web3 toward the end, but this is a complete guide from start to finish of essentially all web development technologies that are used today. I do have some stuff underlined, and that's just to let you know what I prefer personally. I'm not telling you you should use that. I'm just letting you know my personal preference because a lot of people ask me that. And then one thing I've changed from previous years is I used to put the names of videos on my channel that pertain to that particular technology that we're talking about. I used to put those in the sidebar, but this year I've actually added a page to my website that kind of goes along with the topics here with links to videos and courses for each section. So you can check that out. I'll put the link in the description for that. All right, so before we get into specific technologies, let's first talk about your overall goal and why you even want to code or why you code. So if writing code interests you, there's a few paths that you can take. And that's what I really love about writing code is you're not bound to just one thing. In fact, you could bounce around between a lot of these choices. I have myself. So I would say that the most common reason that people want to learn to code is to work for a company. Developers make a pretty good living, and a lot of us are passionate about it. So it's great to be able to go to work every day and do what you love. That's a dream for many people. And technology isn't going anywhere anytime soon, so you also have a lot of job security. So some people, including myself, like the idea of freelancing and running your own business. You can set your own hours, be your own boss, but it does take a lot of discipline to work for yourself. It can also get kind of lonely, so it's not for everybody. It has its pros and cons just like everything else. Another option is to build your own products or SaaSes, which stands for Software as a Service. This could be anything at all. Some examples could be selling your own templates or plugins. You could build something, let's say some kind of patient management portal or, an online photo editor, something like that. I mean, the possibilities are endless to what you can create and what can help people out. So it does take a lot of work and marketing to create successful products. You will probably have some failures, but that is a path you could take. You could get into my wheelhouse of creating educational content, although this isn't really something that I would suggest that you start with. It's a little weird to learn how to code and then go right into teaching without any experience unless you've done it as a hobby for years, which actually brings me to my next option, which is to code as a hobby. It's absolutely fine to learn how to code and not use it to, as your living or whatever, to make any money from it. And you might even start as a hobby and find out that you're able to build something that can help a lot of people out, and you end up making a lot of money down the road. But my point is that there's a lot of different roads you can take. If you decide to take a certain road now, it doesn't mean you can't change it later. All right, so another thing that you're going to want to think about is what type of developer do you want to be or do you want to start with? Certain technologies are used for different parts of a website or a web app. So a front-end developer typically works on the client side or with the browser, and that's called the front end. So they build user interfaces, which is obviously the part of the application that the user deals with. Some typical tools that front-end developers need to know are HTML, CSS, JavaScript, working with the browsers, document object model, and they'll most likely be working with some kind of front-end JavaScript framework. So backend developers work with the server side, and that could be any kind of programming language. So you can use JavaScript with Node.js, but on the server you can also use PHP, Python, C#, Golang. There's a lot of different languages you could use, and I'm going to go over those later. And backend devs usually model data and also work with some kind of database. And then a full stack developer works on both the front end and the back end. It's also important to mention that these days, that line that separates the front end and back end is becoming more blurred. And as far as my audience and my viewers, I know that most of you guys are into full stack development. Now, these icons or these images on the side here, I'm going to label when something is front end, back end, and full stack with these icons. And a lot of what I'll be mentioning isn't mandatory that you learn. So if it is, I'll have a check mark along with the icon. All right, so there's only a few basic tools that are really required when we start doing web development. So obviously you need a computer to write code and you need an operating system on that computer. As far as the computer, you don't really need a powerful machine for web development. You can get just about anything from the last 10 years and it's fine for just basic web development. But I would suggest at least 8 gigabytes of memory. As far as the operating system, everyone has their own preference. There is no best operating system. I personally prefer Mac OS, but I also have a Windows machine that I use quite a bit. I run Linux on any servers that I have, and I'll talk more about servers later. You also have the Windows subsystem for Linux. Web browser, same thing. I prefer Chrome just because that's what I've used for the past decade or so. I do like the integrated developer tools, but all browsers these days have those to some extent. Firefox is also very popular with developers, and recently I've actually heard of a lot of people using Brave. Microsoft Edge, along with Brave, they're based on Chromium, so I mean any of these will really do for web development. So as far as writing code, you need a text editor or an IDE, which stands for Integrated Development Environment. So Visual Studio Code or VS Code is my favorite text editor and seems to kind of dominate at least the web development world. It's fast, it's intuitive, it has great extensions, it's free, it has a great community. But there are some others. Sublime Text is pretty popular. Vim is the successor of VI, which is a Unix-based text editor. And it seems a little difficult to learn, but people that use Vim seem to really love it. Okay, so the terminal is not something that you'll need to know right away, and if you're a front-end developer, you definitely don't need to master it, but you should know the basics when it comes to just navigating between folders and files. There are command line tools that you'll be using no matter what type of developer you are. As far as which terminal you use, that's up to you. The default terminal is fine. That comes with Windows, Mac, whatever. I like iTerm for Mac OS. Windows users have PowerShell. They have WSL. I like to use a program called Git Bash when I use Windows. It's a very simple Unix-based terminal. And then you also have Hyper. It's very customizable. You can install extensions and so on. All right, so a lot of people ask me if they need to know any kind of design software. And in my opinion, if you're a front-end developer or a web designer, you should learn at least the basics of some kind of design tool. And if you're freelancing, you're most likely going to have to provide mock-ups to your clients, and you might want to know one of these. So some of the big ones, we have Figma, which is great. It runs right in the browser. It's powerful. It's free. I like Adobe XD just because I used to use Photoshop and Adobe Illustrator. And Photoshop is really geared towards photos. So I switched to Adobe XD because it's more geared towards UI design. That's what I prefer, but I would probably recommend Figma for someone that's just getting started. You also have Sketch, which is pretty popular, but I believe it's only for Mac. And then there's some others as well. Canva is a tool that you can use right in the browser. I'm not sure if it's free or not, but that's something that I see a lot of people using these days as well. All right, so HTML and CSS are always going to be the first web technology that you learn because they're the building blocks of the web. And no matter how sophisticated your web app, no matter what the language on the server you're using or what front-end framework you're using, in the end, it's going to be HTML and it's going to be styled with CSS in the browser. So typically you're going to learn both HTML and CSS at the same time, but you're going to focus most of your time on CSS just because it's much more difficult and there's just a lot more to learn than with HTML. So I think no matter what type of developer you are, even if you plan on being a backend developer, you should at least know the basics of HTML and CSS. So some things you want to learn. basic paragraph and heading tags and all that, but you also want to learn your HTML5 semantic tags like header, footer, section. It's really important to lay your pages out correctly with these semantic tags over just a bunch of divs. Then you want to get into CSS fundamentals, basic properties that have to do with colors, fonts, borders, margin padding. You want to understand the box model and how that works. And then alignment, of course, is really important. So Flexbox and Grid, both of those are great tools. I mean, I come from the days of using floats and tables for your layout, and I can tell you that CSS Grid and Flexbox are just, they're godsends for web developers. So I would learn both. I tend to use CSS Grid for my overall layout, but Flexbox for aligning inner elements. And then media queries and responsive design. So I would say now in 2022 and maybe the past 7 or 8 years, I would say it's mandatory for everything that you build to look decent on a mobile device. Before that, it was kind of optional, but now with the amount of mobile device use, I think that it's mandatory that all your layouts look good on mobile devices. So simple animations and CSS transitions, they're not really crucial at this time, but you might want to just learn the basics of having something fade in and fade out and so on. All right, so as far as extra tools that you can learn at this point, Sass is a CSS preprocessor. There are others like Less and Stylus, but Sass is definitely the most popular. You can basically create Sass code, which is similar to CSS, but gives you some extra functionality, such as variables, functions, and mix-ins, and nesting. I do think that Sass is going to get pushed out because native CSS already has custom properties, which are basically variables. We're going to have nesting in CSS, and I think that there's going to be much less of a need for Sass. But with that said, I think you should learn it just because it's pretty easy to learn. There's just some extra features to learn, and then you just compile it with a Sass compiler down to CSS, and you include it in your projects. Also, if you really want to customize any CSS framework like Bootstrap, a lot of the times you'll use Sass for that, so that's another reason to learn it as well. And you could literally learn it in a weekend. So you might also have heard of PostCSS, which is a different thing. PostCSS is a tool for transforming CSS with JavaScript. It's used in a lot of bundlers like Parcel, some others, which I'll talk about later, but you can do a lot of the same stuff that Sass does by installing specific plugins. I personally don't use PostCSS that much, and I wouldn't suggest learning it at this point, but it might be beneficial to learn in the future. All right, so before you go on to learn JavaScript, you have the option to learn a CSS framework, and these frameworks basically give you predefined classes to style elements. Now, one thing I really want to stress here is that it's extremely important, at least in my opinion, to learn CSS before jumping into a framework. Once you can create just a decent looking website with HTML and CSS, then you might want to look into a framework because they can really help you speed up your projects and minimize the amount of CSS that you write, or eliminate the need to write CSS altogether. So let's take a look at some of these. So Bootstrap has been around for a long time. It's currently on version 5. I would say that it's the most popular to date, at least in my opinion. I think it's worth learning for the simple fact that you'll probably run into it at one time or another. Also, if you learn Bootstrap and you understand how it works, then you can pretty much use any framework, at least at its core, by just remembering or looking up specific classes. And Bootstrap also gives you a bunch of cool JavaScript widgets like drop downs and collapsible menus and things like that, hamburger menus. So I think it is worth learning. I think that it can really help you speed up projects. Now, Tailwind is a bit different than the rest of these. Tailwind is a low-level utility-based framework, so let me kind of explain what that means. So Bootstrap is a high-level framework, meaning that it has classes like button or alert, and that one class will contain a lot of different styles like the background color, the border radius, the margin, and all that. With Tailwind, Tailwind provides very low-level classes that do basically just one single thing or one property. So you might have a class of text center, which will just add a text align center property, or you might have just one single class to add a little margin. So very low-level stuff. Now, with Tailwind, the negative is that you write a lot more classes in your HTML, so it does really clutter up your HTML. The benefits is that for one, you don't have to write any CSS, but you can also customize things better where not all your buttons and your elements look the same as every other website that uses Tailwind. You do see this a lot with Bootstrap and other frameworks. So, I mean, there's pros and cons to both. I usually suggest Bootstrap first because it's easier to learn and think that it's more popular. You're going to end up seeing it more in the industry. So at least at this time. So Materialize is another framework similar to Bootstrap. It has classes as well as JavaScript widgets. It's based on the material design pattern by Google. I've always liked Materialize. I like the look of it more than I like the Bootstrap stuff. But I do think that, again, Bootstrap is much more popular, so that's probably what I would recommend first. Balma is another nice looking framework with CSS components. It's really modular. It's also mobile first, like most of these other ones. I don't think it has any JavaScript tools though. And then Foundation is a well-established, full-featured UI framework that's been around for quite a while, but it is still being used even by some pretty large companies. And it can be a bit more advanced in its tooling, but it's very customizable and it is a nice framework. So there's others as well. But like I said, once you learn how CSS frameworks work, essentially, then you can basically use whichever one you want. All right, so this is something that I think is really important to understand as a front-end web developer or a web designer, and that's UI design principles. So if you're working at a large company, they may have designers that create mock-ups, and then it's your job to kind of take that mock-up and make it display and work in a browser. However, there are some companies where front-end developers do have a lot of say in the design, and if you're freelancing, of course, unless you're outsourcing all of your design work, you're going to be creating some layouts and doing some design. So I think you should at least have somewhat of an eye for design and understand some general principles. All right, such as color and contrast. You want to make sure the text is readable. We've all seen the websites where there's a big hero section and an image where there's text on top of it and you can barely read the text because there's no overlay. Things like that. You don't want to make those kind of mistakes. White space, you want to make sure that you don't have too much or too little space in between elements. You want to make sure your elements are sized and they scale correctly relative to each other. You want to make sure everything on the page is arranged in order of importance. Typography, so nicely formatted text, typeface, sizing, etc. So these are just some really simple but really important things to pay attention to if you're doing any kind of design. All right, so up to this point, we're creating basic websites and making things look nice. Now it's time to get into a programming language, and if you're a web developer, you should know JavaScript. It may not be the main language that you work with if you're going to be a back-end or a full-stack developer. You can build websites using server-rendered pages and a template language with, PHP or Python. But if you want any kind of dynamic functionality within the browser and you want to have interactivity and just a modern web app, then you'll need to know at least some JavaScript because that is the language of the browser. So JavaScript front-end frameworks are extremely popular, but I think in some cases people move to them too quickly. So here's some important parts of JavaScript that I recommend learning before moving to a framework. So the basics of JavaScript are the things that you use in just about every project, so it's important to understand them. Things like data types, data structures like arrays, objects, you have functions, loops, things like that. Things that aren't just relative to JavaScript, but these are in basically every programming language. They're just basic principles. And once you learn them, it makes it easier to learn new programming languages later on. So in web development, the DOM, or Document Object Model, is really important. The DOM is it's an interface in the browser that treats HTML documents as a tree structure of nodes. So all the HTML tags in the document are part of this structure. And nodes can be selected, manipulated, and can have event handlers attached to them. This allows you to have dynamic web pages. So you can have, when you click a button and something happens on the page, that's when you're working with the DOM. You're making things happen, whether it's making something a different color, or making something show or disappear, or making a request to some kind of server and then showing some data, things like that. So I would suggest learning how to work with the DOM using vanilla JavaScript before moving to a framework. Asynchronous programming is important in JavaScript. Many times, instead of waiting for a task to finish, such as getting data from a server, we want things to keep moving on. So we use asynchronous coding. So it's important to understand things like promises using the .then syntax, or I should say .then, .catch syntax, also async await, callbacks, things like that. And then the fetch API is also something that I would suggest learning, because it allows you to make requests asynchronously to a server, and you can get data, you can post, update, and delete data. A lot of front-end developers, a lot of their job, or part of their job, is to make requests to APIs and then use that data in their user interface. So you should also fully understand JSON, or JSON, which is JavaScript Object Notation, because this is the most common format for APIs, or API data. There is XML, but you don't see that much these days with modern APIs. So array methods are also something that you'll use quite a bit when dealing with arrays of data. So for each, map, filter, reduce. There's a lot more, but I would say that you should be comfortable with the most common ones. And algorithms are a great way to kind of practice these. So, I mean, that's what I suggest that you learn before moving to a framework, but obviously everyone's different. Everyone has different views on that. So let's talk about some other tools that you're going to be running into around this time in your learning journey. So Git is one of the tools that every developer of any kind should be using. It's a version control system to track changes in your code. There are other systems. You have Subversion and some others, but Git is by far the most popular. And it's used for versioning, backup, as well as collaboration. It's extremely helpful if you have multiple people working on a single project, because it allows you to see who did what and see exactly when they did it. And you can roll back if you want, things like that, create new branches. These are some of the things you should be able to do. And you should also be able to work with a remote service like GitHub or GitLab or Bitbucket. GitHub is obviously the most popular of those. And then Markdown, I don't have it here, but it is something that you'll want to start to learn as well, because you use it in Git to display your documentation or your README files. And Markdown is really easy to learn. You could learn Markdown in like 2 hours. I have a crash course on it. If you're interested, just learn it, or create a cheat sheet just so you can look up the formatting characters, but it's very easy. So NPM stands for Node Package Manager, and it's the official JavaScript package manager. Packages being code that does a specific thing. It could be a framework, library, plugin, or some kind of helper. Just about every language has some kind of package manager. But since JavaScript is what runs in the browser, many front-end developers need to know NPM. Now, there is another package manager called Yarn that's pretty popular, and you can use that instead of NPM, but they both share the same NPM, they both share the same repository of packages. All right, browser dev tools are extremely valuable when it comes to debugging, viewing the page structure or the DOM, browser storage, network activity, and so on. It gives you a good picture of what's going on in the browser at that time. So all browsers have some kind of developer tools, and I would definitely suggest that you get familiar with those, familiar with all the tabs in the dev tools. Next, we have text editor or IDE extensions or plugins. So most text editors have the ability to add third-party extensions to kind of increase the functionality. Most developers find a certain suite of tools that they like to work with, helps them code in a more efficient way. So browse around, see what you think will help you out. Emmet, I just want to mention because that's an incredible tool for writing HTML and CSS with quick snippets, and it's available with VS Code by default, but you do have to install it as a plugin on many other text editors. And then Live Server, Prettier, ESLint, GitHub Copilot, these are some of the extensions that I use all the time. And I'll talk more about GitHub Copilot later. All right, so now that you know HTML, CSS, JavaScript, and some tools, you'll need to know how to deploy your projects to the internet and not just your local machine. So you have quite a few options for this. As far as platforms, I really like Netlify and Vercel. Both of these are simple to use. You can just create a GitHub repository and then log in and just select the repository that you want to deploy. So they're great. They have very generous free tiers as well. And you'll want to add your own domain name. So domains can be $10 to $15 per year, so they're very cheap unless you're buying an already existing domain off of someone. Then they can get really expensive. And I use Namecheap. This video isn't sponsored by anybody, so any companies that I mention are just companies that I've used. And then you also have companies that offer like shared hosting and VPSs and dedicated servers, companies like HostGator, Bluehost. Most of these use cPanel, which is a management console for your hosting account where you can set up your email and analytics and things like that. There's so many different choices. I'm not going to really get into it. And I'm not mentioning platforms like AWS or Heroku or anything like that because I'm going to mention those later on when we get into backend and full stack. As far as actually deploying, you have a few different ways. You have Git, with most platforms allow you to use, which is great. It's very fast. You can set up continuous deployment. SSH is a secure shell. You can log in through your terminal. You can do things that way. SSH is something you should learn a little later on. And then FTP, which is the file transfer protocol, is kind of the old school way of doing things and can be very slow. So I would suggest that you do literally anything else other than FTP if possible, if your platform allows you. All right, so we've talked about all the basic knowledge that you should know up to this point, along with some extra technologies like CSS Frameworks and Sass. So at this point in your career, in order to be a basic front-end developer, at least in my opinion, you should now be able to create websites with HTML and CSS. You don't have to be a designer, but you should be able to create or take a mock-up and create a website from it. Now, even though you're not a designer, if you plan on being a front-end developer, you should know at least some basic design principles and know what looks good and what doesn't. You should know JavaScript pretty well and be able to work with the DOM and do things like create a dynamic navigation or create a modal, something like, things like that. You should be able to create basic front-end applications using JavaScript. So, just very simple apps with vanilla JavaScript. You should be able to use the Fetch API to make requests to either a backend or a third-party API, fetching data, bringing it into your application, and so on. You should also be able to work with Git, create branches, push to a remote repository, whether it's GitHub, GitLab, or whatever. You should also be able to deploy and manage small production projects. So you should have some kind of process with a specific platform that you're comfortable with. And as far as getting a job, I think at this point you can start applying for front-end positions. However, these days you'll probably need to learn a front-end framework, which we're going to talk about soon. So you're at kind of a crossroads now, and you have a couple of options as far as what you want to learn next. And I'm just going to go over those options. So the first one I think is web design, and I feel like this option is really left out when it comes to like YouTube and courses and people that you watch online. This is if you really want to get into the visual design part of web development and learn how to create great layouts. So you're going to learn a lot more advanced CSS, probably get into animation and transitions. This could be a viable option, especially if you plan to freelance. There's a lot that you can build and do with just HTML, CSS, and JavaScript. You can create beautiful brochure sites with some dynamic modals and pop-ups and all that. You might even get into WordPress or some no-code tools like Webflow. I know a lot of freelancers that went this route and are actually very successful. You also have the option to start learning a front-end framework now that you know the fundamentals of JavaScript. Frameworks make building interactive UIs much easier and much more organized. The framework that you want to use is up to you. We'll talk about that next. And you'll also be getting into like state management and all that. So if you plan to be a backend developer, then you probably skip the front-end frameworks and start with either a new language. I mean, you can stick with JavaScript and Node.js, or you could use PHP, Python, Golang, C#, and many other options. You'll also be working with databases like Postgres, MongoDB, and so on. And you have another option to just continue to master JavaScript as a language by doing things like algorithms and building more advanced vanilla JavaScript applications. You could get into more advanced tools like module bundlers, Webpack, Snowpack, Parcel. These are used to bundle your JavaScript, and you can create more advanced vanilla JavaScript applications. I probably wouldn't suggest this if your goal is to make money, but if you're coding as a hobby, then this might be a route to take. All right, so with these suggestions, if you plan on being a front-end or a full-stack developer, I would highly recommend that you go with the option of learning a front-end framework. Most companies are looking for people that know a framework. It's also, makes things easier if you're dealing in the front end. So that's what we're going to look at next is front-end frameworks. Now, when I say front end, that refers to the client side and what are called single page applications or SPAs. And this means that the browser only loads a single page and then everything else is done through JavaScript using the framework. Now, there are ways to run frameworks on the server side, which I'll talk about soon. That's actually becoming really popular. But these are inherently client-side or front-end applications. And we build our user interfaces with something called components. And components are encapsulated pieces of code that usually include the output or HTML as well as the JavaScript logic and even sometimes the styling. So these frameworks, they all essentially do the same thing just in different ways. So first we have React, which is the most popular framework by many metrics. It's technically a UI library, but it's in direct competition with all the other frameworks. It was created and maintained by Facebook. As far as a learning curve, I'd say it's pretty moderate. Some of the things that you'll be learning along with the core library of React is React Router, JSX, which basically allows you to have HTML in JavaScript, hooks, which are used in functional components, the context API, and Redux, which are used for managing global state. Redux, I'd say, is becoming a little less popular now that we have context and hooks, but it is something that is still widely used. And then Vue.js, I would say, is the second most popular framework, at least from my own research. It doesn't have the backing of a huge company like Google or Facebook, and it still made it to where it is. So that shows you that it's a pretty damn good framework. And there's a great community around it. It's fairly easy to learn when you compare it to React or Angular. The Vue CLI is used to scaffold up and manage Vue projects. The Vue Router, the Composition API was introduced with version 3. So these are some things you'll be learning with Vue. Vuex is a state manager similar to Redux. So Angular is still pretty popular in the enterprise world, but not so much around startups and smaller companies and, in the learning community on YouTube and so on. You don't really see a lot about Angular. It was created by Google. I would definitely say that it has the steepest learning curve of the four, at least in my own opinion. But it is also a much larger framework and includes a lot more in the core packages. It has its own router, it has an HTTP client, and so on. It also uses TypeScript by default. So you'll be learning that stuff. You'll be learning about the Angular CLI. There's a concept of services that Angular uses a lot, observables for asynchronous code. And then we have Svelte, which is technically not a framework. It's a JavaScript compiler. So you build your app in a certain way using Svelte files, and then you run it through a compiler and you get pure JavaScript. So no framework code whatsoever. So it is very lightweight and it's very performant. And I actually love Svelte. And if I wasn't into teaching and I was just building my own projects, I would probably switch to Svelte from React, just because it's easy to use, and it just feels like when you do something, it just works, and it's not overcomplicated like some other things in other frameworks. But choosing is up to you. Don't listen to anyone that says X is the best framework. A lot of it is just preference. Of course, popularity does matter if you're looking for a job. So just look at listings in your area, see what's being used. And my advice would be to try all of them and just see what really clicks with you. All right, so the next technology that we're going to talk about is TypeScript, which seems to, a lot of people seem to either love it or hate it. Not always. In fact, I don't love it or hate it. I do see the value in it, but I'm not someone that thinks every project should be done in TypeScript like a lot of other people do. And TypeScript, it's a superset of JavaScript, meaning that it includes everything that JavaScript does. So it essentially is JavaScript, but it has some additional features. And the main additional feature is static type checking, hence the name TypeScript. And JavaScript is not a typed language by default, meaning that when you define a variable or a function, you don't have to say that this variable or this function returns a string or a number or a Boolean. It's interpreted for you. Well, some languages like Java, C, C++, these are statically typed, which means you need to define the actual type. And even though you're writing more code, there can be a lot of benefits to it. So TypeScript adds the option to add types to JavaScript, and it is completely optional to add types. It also offers class and module support, other ES6 plus features. Your code is less prone to errors when it's statically typed, and your code is more robust and definitive. So there are benefits, but again, it's up to you to weigh the pros and cons and decide if you want to learn it. So now that you know front-end framework, you have a lot of choices for styling and design. Of course, you can just have a global style sheet, CSS style sheet, but there's other options as well. Styled components is something I would urge you to look into. But you also have these UI kits or libraries that you can use that give you these pre-made components, visual components, things like alerts or menus or whatever it might be. You can look at all the documentation to see what's available. So just to give you an idea of some of them, so for React, you have Material UI, which is based off of Material Design. And I would say this is the most popular for React, at least in my experience. Chakra UI is one of my favorites. I think that it's pretty easy to use. There's not a ton of code that you have to write to have to create a component, and it looks really nice. Onsen UI, I believe, is available for everything here, but it's geared more toward mobile apps. And then React Bootstrap, as it implies, it's a UI library based on the Bootstrap CSS framework. So for Vue, Vuetify is definitely my favorite. It has a ton of professional looking interactive UI elements. I will say I think this is the most popular by far. Vue Material is another material design based UI kit. You have Buffy, which is actually based on the Bulma CSS framework. And then Bootstrap Vue, of course, is based on Bootstrap. For Angular, you have Angular Material. Again, this is material design. NG Bootstrap, NG Zorro, which is an enterprise class kit. It's based on the Ant design, but I've never used this. And then MD Bootstrap as well. And then for Svelte, you have Svelte Material UI, Smelt, which is one I haven't used yet but looks interesting. It's based off of a combination of Svelte and Tailwind. And then Svelte Material, Materialify, and Svelte Strap. All right, so testing is something that I have often said that I don't do enough of. I seem to hear this from a lot of developers. I think some people feel that the trouble and time that it takes to test your application isn't worth it. And I do see that argument, especially for smaller applications. However, once you take the time to learn how to test, I think you'll see that there are benefits that really make it worth it. And there's a lot of different types of testing. I'm not going to get into all of them, but three of the most popular types. You have unit testing, where you test specific blocks of code, usually functions, modules, classes, etc. You have integration testing. Is usually done in concert with unit testing. Unit testing tests blocks of code, and integration testing will test how those blocks of code work together. And then end-to-end testing does just that. It tests from beginning to end and ensures that the application flow behaves as expected. As far as tools, every language has testing tools. JavaScript has frameworks like Jest and Cypress. Oftentimes, when you use something like Create React App, for instance, it'll have testing tools built in. Like React has the React testing library. This is something that you'll need to decide if you want to learn or not. If you're freelancing and you're building relatively small applications and websites and don't see a need for testing, I personally don't think that there's anything wrong with that. So server-side rendering, I think, is probably my favorite thing about modern web development over the past couple years. And we're getting away from single-page applications a little bit. And this is where we render React, Vue, and these inherently front-end frameworks on the server, which gives us quite a few benefits. So SEO is a huge benefit. When you use a single-page application, everything is loaded through JavaScript, so search engines can't really crawl your site. But with server-side rendering, it allows Google and other search engines to see all of the content on the page. We also have performance benefits. Routing is much easier. You just upload a file, just add a file to a specific folder, and your route just works. You don't have to manually create all your routes. So there's a lot of benefits to this. As far as the actual frameworks, you have Next.js, which would be my pick, but this is based on React. So if you're a Vue developer, you're probably not going to use Next.js. You're going to use Nuxt, which I'll talk about in a minute. So Next.js has been around for a while. I think it's fantastic. You can render your pages on the server, and you have access to specific data fetching methods where you can run server-side tasks, and you have access to the HTTP request data before the page loads, something that you can't do in a regular Create React app application. You also have extra tools like image optimization, so Next.js is a great framework. Nuxt.js is very similar to Next, except it's not for React, it uses Vue.js. So naturally, if you're a Vue developer, you're probably going to use Nuxt, but it has a lot of the same benefits that Next has. Now, Remix is a very, very new framework for React developers, and I've been getting into it recently. I just did a 2-part crash course on it. Although it shares some features with Next.js and does some of the same things, it feels very different. And they have something called loaders and something called actions, where you can submit data to the server and you can do everything within Remix and not have to have a completely separate backend. And I don't know, I really like it, and I like where we're heading with it. So SvelteKit is your option for Svelte. I honestly would suggest using SvelteKit for just about any Svelte app. It offers server-side rendering, advanced routing, code splitting, and much more. Another thing that I don't have listed here is Angular Universal, which does do server-side rendering for Angular apps as well. All right, so the next batch of technologies that we have are static site generators, which allow you to generate your website and content using data from various sources. It could be markdown files or some kind of API. It might be a headless CMS, which I'm going to talk about next. Static sites are very performant because they get all the data ahead of time and then preload it. So when the user comes to the page, everything loads very, very fast. So we have a few options for this. React has a framework called Gatsby, or I should say there's a framework called Gatsby that uses React, and you create pages that are simply React components. So you can still structure everything as you would in a regular React app. You just have some extra capabilities. And Gatsby has an extra GraphQL data layer that you can work with. And I know I haven't gone over GraphQL yet, but I will in a bit. Gatsby has all kinds of features such as image optimization, code splitting, and so on. Now, we already talked about Next.js rendering React on the server. However, it can also be used as a static site generator. There are some specific rules that you have to follow in your code in order to do this, but you do have an export command to export your project as a static site. And it has data fetching functions for fetching whatever you want, as well as creating dynamic URLs for your static files. So I would use Next.js over Gatsby, but that's just because I work with it more than I do Gatsby. So Gridsome is very similar to Gatsby, but instead of React, it uses Vue.js. So naturally, if you're a Vue developer, you'll probably use Gridsome. It has a bunch of features for progressive web apps, SEO, and more. Now, Jekyll is a static site generator that has been around for a long time, and it's not associated with any JavaScript framework. It's actually a Ruby-based, and it uses the Liquid template engine. So there are a lot more static site generators that are not, for React or Vue or whatever. There's some PHP-based ones. There's some Golang ones. I believe Hugo is based on the Golang programming language. So just something to look into. All right, so when we think of a content management system, a lot of us, especially if you've been doing this for a while, you think of WordPress or Drupal. These are systems that allow you and your clients to have some kind of admin area to log in and manage your content, which is great. And a headless CMS basically has that back-end admin functionality where you can edit your content, but there's no front end like there is traditionally with WordPress, Drupal. So you're free to use whatever you want on the front end because the content management system just spits out a JSON API. So you can use React, Svelte, no framework at all, and use your CMS data to create pages, menus, and so on. There's also authentication systems built into a lot of these, and you can use tools like Auth0. So these are great, and I think that these are just going to get bigger and bigger because it takes away a lot of the work when it comes to creating your back end and your server. So Strapi is currently my favorite. It's completely open source and self-hosted, meaning that you set it up yourself on your own server, unlike some other systems where your back end is hosted on their servers. You can create content types like you would in WordPress. There's a plugin system. It's just a really powerful, and it's definitely my favorite and what I have the most experience with. Sanity.io is a great headless CMS. It's powerful and a flexible platform. It's free up to a certain point, but there are some pricing tiers that you can look at. And looking at the features of Sanity, it seems like a great choice for collaboration. The way the content is structured, it makes it easy to have multiple people working on the same project. And there's also a really cool toolkit called Sanity Studio that you can use as well. Contentful is a headless CMS that seems to be really popular in the big business world. It has features that are great for teams. It's optimized for speed and performance. And then Graph CMS is something that I recently discovered, and it allows you to instantly create a GraphQL API. And we'll talk about GraphQL soon. So I think that we're going to continue to see these just grow in popularity, like I said. All right, so the last few slides we looked into can fit into something called the Jamstack, which is a very broad term for an architectural approach of building websites. And it was originally presented with a capital JAM, which stood for JavaScript APIs and Markup. And from what I understand, they got rid of that acronym as it's defined more broadly. And you can visit jamstack.wtf to really get into it and look at all the technologies. But it does include a wide variety of tools and technologies, a lot of which is like static site generators along with a headless CMS. There's also certain platforms that are great for the Jamstack, like Netlify and Vercel. Everything is decoupled. The front-end tooling is separate from the back-end. Like I said, the front end is typically built with a static site generator. You can also use serverless functions, which I'll talk about in a second. It's static first, so while there are dynamic elements, most Jamstack pages are pre-rendered, meaning that the front end was compiled into HTML, CSS, and JavaScript. So serverless functions are very beneficial. It takes away the knowledge, time, and effort and the cost of deploying and managing a server on your own. So if you need something done on the server side, you can create a serverless function or a Lambda function and run it on Netlify or Vercel or any other platform that supports serverless functions. Jamstack is very high performance, secure, and scalable since everything is pre-rendered. And there's not really any SQL injections or other database vulnerabilities because, again, it's all pre-rendered. You're not dealing directly with a database. Okay, so we've talked about a lot, and I don't want you guys to get overwhelmed, and I just want to encourage you to just think about this stuff as the options that are out there. You're not expected to know or to learn all of this. So by now, you should be able to build user interfaces with a front-end framework. You may also learn something like style components or a UI library. You should understand how to work with local and global state. This could be using the context API for React, Redux, or Vuex with Vue, or whatever else. So you should understand quite a bit about HTTP when it comes to making requests to a server from the front end and getting a response back. You should know how to work with REST APIs. You may even work with GraphQL. I saved that for later because in addition to the front end part, you have the GraphQL server as well. And then as for added skills, you may know how to use TypeScript. This is optional, but is getting more popular every year. So I think working with server-side rendered pages is going to become more and more popular, as well as frameworks like Next and Remix. Also creating fast websites with static site generators and maybe headless content management system. I think that stuff is on the rise as well. You may do some testing with a framework like Jest. People seem to learn testing at their own pace. All right, so now that we've gone over all the front-end technologies, let's start looking at some server-side or back-end technologies. So first we have languages. JavaScript is the language of the browser. That's why we talk so much about it in the front end, but the server can be any language you want. So let's just take a look at some options. So Node.js is a JavaScript runtime, so it's essentially JavaScript on the server. Node is fast, it's asynchronous, it uses event-based programming, it has a rich ecosystem, it's great for APIs, microservices, real-time applications. Where it falls short is CPU-heavy tasks. That's not something that I really deal with, so Node.js is perfect for me. That's what I prefer, but again, you don't have to use what I use. And then there's another option if you want to use JavaScript on the server, and that's Deno. It had a lot of hype like a year or a year and a half ago, but I don't know, hasn't lived up to that hype. I do think there is a place for it in the future because it has some great features, but it's not something I would recommend getting into right now. Python is great for a lot of things. I've used Python quite a bit and I love it. It's number one for things like data science, machine learning, and AI. It is also great for web development. There's some awesome frameworks that I'll go over, but Python is definitely a great choice for web development. PHP gets a bad rap. I think that its reputation is getting better, but I would suggest that you don't listen to the stupid memes about PHP. It is a great scripting language. It's not the prettiest, but it's very efficient. It's still widely used, and it's great for like freelancing and small business. C# is a general purpose language. It feels very clean, and it uses the .NET framework. You have some ASP.NET, which is very popular. I don't use C# that much, especially for web development, but it is a good option. Golang is extremely powerful. It was created by Google. I've built a few simple APIs with it, but I don't have a lot of experience with it, so I can't give you too much of an opinion. I know it's used on large-scale servers and big distributed systems. It can also be used for just basic web development as well. Ruby is a language that I worked with for a few years and really like it. I think the syntax is very, very clean. It's almost like writing English. When we talk about Ruby for web development, we're usually talking about Ruby on Rails, which is a framework, and I'll talk about that soon. So Java is another language that is used in a lot of ways. It's also used for web development. The Spring Boot framework is pretty popular. I personally think Java is a great language to learn like basic programming principles on, but I haven't really used it for web development. But it is used, especially in like the enterprise world. Kotlin is a relatively new language that was designed for the Java Virtual Machine, or the JVM. So in many cases, Kotlin is replacing Java. It's widely used for Android apps, but it can also be used for web development. And then you have Rust. So Rust has sort of a special purpose, and that is that it's popular with WebAssembly, which I'll go over later. However, Rust is a viable option for backend web development. It uses Hyper as a core HTTP server and can be great for things like microservices. Scala is another option for backend web development. Like other languages, it combines object-oriented and functional programming. It powers the data engineering infrastructure of many companies, but can also be used for building APIs and microservices. So R, or Erlang, is not a language that I have any experience with at all. I've done a little bit of research on it, and it seems like it's fantastic for statistical computing, data analytics, scientific research. It's very powerful for that stuff. It does a lot of what Python does. For web development, you could use R with Markdown and the Knitter engine. There's also a package called Shiny that lets you create web pages, but that's about all I know for R programming. And then Swift is a popular general purpose language, but it's mostly known for developing mobile apps, in particular native iOS apps, along with Objective-C. Swift can be used for web development, so I did add it here. However, there aren't many tools available, at least from what I could find. So that's not something I would suggest for web development, or at least for your first language. All right, so as with the front end, we also have web frameworks for the back end, and every language has them. So web frameworks are designed to handle HTTP requests and send a response. They also give you a bunch of extra tools. Some frameworks are they have more to them than others. Some are very minimalistic. So let's go over some for some of these different languages. So for Node.js, Express is definitely the most popular framework. There's a lot of other frameworks built on top of Express as well, because it is very minimalistic, which means that you have complete freedom to build and structure your code and your files however you want. And companies like Twitter, Uber, IBM have all deployed apps built on Express. Fastify is a newer framework for building web apps and APIs. It's something that I started working with in 2021 and really liked, and I could see myself using Fastify in production. Like its name implies, it is super fast. It also has a powerful plugin architecture with documentation tools and much more. Koa is another minimalistic option. In fact, I would say that it's very similar to Express in what it offers and its syntax. And then Nest.js is a fairly opinionated framework, but it does offer a lot. It's built for enterprise. It includes TypeScript by default, and it actually reminds me of Angular, the way that everything is structured. So if you're an Angular developer, Nest.js might be a good option for your backend. Adonis, I don't have that here, but it's another really high-level opinionated framework for Node.js that kind of reminds me of Laravel. So for Python, there's two really, really great frameworks, and that's Django. So Django is probably one of the best frameworks, in my opinion, period, out of any language. It's very high level. It allows you to build pretty complex apps and APIs in a short amount of time. And it even generates an entire admin area with almost no written code. And it's very specific, meaning you have to build things the Django way, but you do get a lot for it. It's also very fast and scalable. And I barely knew Python when I learned Django. That's how much it gives you out of the box. And then Flask, I also think, is a great framework, but completely different from Django. Where Django is very high level, Flask is closer to Express. It's very minimalistic and gives you the freedom to do things however you want. So both frameworks are great, but there's a big difference in them. Fast API is a framework for building fast APIs, which isn't very surprising. It's high performance, and it's on par with Node.js and Golang, fairly easy to use. I do plan on doing a crash course on Fast API soon. So PHP is a bit different than some other languages because it's basically a template language itself. You can run a PHP page directly in the browser. It does have some nice frameworks, though. Laravel is extremely popular, and I would say on my top 5 favorite frameworks out of any language. PHP sometimes gets a bad rap, like I said, but Laravel gets a lot of respect in the developer community. PHP can be a messy language, but Laravel is actually really elegant and offers just about as much as any framework could offer. It has the Artisan CLI, which is a tool for doing a lot of different things, migrations. It has authentication, templates, validation. So if you're a PHP developer, I would definitely suggest Laravel. Symfony is a set of reusable PHP components, and Laravel is actually built on Symfony components. So you can use Symfony by itself, but in my opinion, it's more difficult than it is to use something like Laravel. And then I wanted to throw Slim PHP in there because unlike, Laravel and some of these others for PHP, it's very minimalistic. It's kind of like Express, but for PHP. And it's great for building APIs. So for C#, you're probably going to be looking at ASP.NET, which is a web platform, and ASP.NET MVC, which is a model view controller framework specifically for building web applications. And I do know C# a little bit, but I haven't really done much web development with it. I've done some desktop, some Windows app development with it. So like I said earlier, I don't have much experience with Golang, but from what I've used and researched, Golang has just a great library where it doesn't really need additional frameworks. But it does have some, including Jin, which is, I believe, the most popular Go framework. Very straightforward, easy to use. BGO is used for rapid development of enterprise applications in Go. All right, so for Ruby, you're probably going to be using Ruby on Rails, which used to be really, really popular. And it has fell off quite a bit in popularity, but I still think it's a fantastic framework. It's great for rapid development. You can scaffold up a REST API in minutes. And there's just a lot of tools included with it. I just think it's a great overall framework. Sinatra is the second most popular framework for Ruby. It's a much smaller framework, and it's sometimes referred to as a micro framework. So for Java, Spring is really popular, and it's actually a programming model and ecosystem that's built on Java and has several parts, such as Spring Boot, which makes it easy to create standalone applications, Spring Cloud, which is a combination of components that allows developers to build cloud-native apps. So I don't have much experience with Java. It was the first language I learned, but I didn't stick with it, so I haven't used it in a long, long time. And then you also have Struts, which is another Java framework for building apps. Kotlin can also use Spring, so Spring 5.0 started supporting Kotlin. And then you have Vertex, which is a framework for Kotlin that is very flexible and resource efficient. For Scala uses the Play framework, which can also be used with Java. Play includes powerful console and build tools, testing tools. It scales predictably. Lift, I've never used, is a Scala framework that claims to be the most secure web framework available. I'm not sure how true that is, but that's the claim. And then for Rust, you have Rocket, which allows you to write fast, secure web apps. It's a type-safe framework that's easy to use. And then Actix is another framework that looks pretty interesting. Again, I think the way you build with this framework is similar to Express. It seems like the code is pretty straightforward and minimalistic. All right, so backend and full stack developers need to work with databases to store data. There's different types of databases. I would say the most popular are relational databases. There's also NoSQL databases that are pretty popular as well. Basically, relational databases store data in tables and rows and typically use the SQL or structured query language to deal with the data. So SQL is probably something you're going to learn as a backend or full stack developer. And then NoSQL databases typically store data in something called collections, which are usually formatted like JSON objects and are very flexible. So like with everything else, it's going to be preference, but here are some of the most common database systems used in web development. So Postgres is my favorite relational database. It's actually an object-oriented, or I should say object relational database, as opposed to MySQL, which is purely relational. And Postgres has some great features like table inheritance and function overloading. Postgres also adheres more closely to the SQL standards, because even though a lot of these databases use SQL, they can implement it in ways that vary from each other. So MySQL is another popular relational database. In many web apps, you won't see much of a difference between Postgres and MySQL, especially small ones. So it's completely up to you. MySQL seems to be really popular in the PHP world. So Microsoft SQL Server is another implementation of an SQL relational database. I personally have never used it, so there's not too much I can elaborate on. So SQLite is a much lighter file-based database that isn't really used in production as far as I know. I've always used it for just development, and it's great for that because you don't have to go through any crazy install process. You just have a something.db file and you can create, read, update, delete data, and I think it's great for development. So MongoDB is a completely different type of database. It's what's called a NoSQL database. But within NoSQL, there's subcategories, and MongoDB is known as a document database. So it holds collections of documents rather than tables of records. So each document is basically like a JSON object. MongoDB is really popular in the Node.js world. You've probably heard of the MERN stack, which is MongoDB, Express, React, and Node. You also have the mean stack or the Maven stack if you want to use Angular or Vue. And since MongoDB formats the data like a JavaScript object, it's easy for JavaScript developers to understand, and it's just really popular within that community. All right, now Firebase is different from the databases that we've already talked about because it's basically an entire hosted platform by Google. It does offer a NoSQL database, but it also offers authentication, file storage, serverless functions. It's an all-in-one platform, and it's great for small to medium-sized projects. The downside is that you don't have full control of the database. It's not something that you can install in your own server. If Google decides to just drop Firebase for some reason, then your project could be in trouble. But I think the chances of that happening are very, very small, but it is something to factor in. I personally love it. So Supabase is an alternative to Firebase. It includes a database, also includes authentication. Now the database, instead of NoSQL, it actually uses Postgres. So it does also have an abstraction layer, so you don't have to write tedious SQL queries. And like I said, it does include authentication and some other stuff. It is completely open source. And if for some reason it did go under, since it uses Postgres, you could simply back up your Postgres database and move it to a new server. So it gives you a lot of what Firebase gives you without that Google lock-in. So I think it's a fantastic platform. It's pretty new, and I think it's gonna be really big. And then Redis is different from the rest. Redis is an in-memory data structure store that is often used for caching. It can be used with multiple stacks. It has different data structures like strings, lists, sets. It has great performance, and it can be used for caching, session management, real-time analytics, or just as a general database. So it's a great tool to learn. All right, so with whatever database you choose, you have an ecosystem of tools. For MySQL, you have like MySQL Workbench, you have PG Admin for Postgres, MongoDB Compass. These are all tools that you use to access your data and manage your data directly. Now you also have something called an ORM, which is an object relational mapper, or an EDM, which is an object data mapper for document databases. And it's basically a layer that sits over your database so that you can query and manipulate data and you don't have to write SQL statements. So, I mean, different languages have different ORMs, and some frameworks like Laravel and Django have built-in ORMs. But some of the popular ones, you have Sequelize, which you can use. I use it with Node.js and Postgres. When I use MongoDB with Node.js, I almost always use Mongoose, which is great. Prisma is a great ORM that I just started working with. A combination of Prisma and an SSR framework like Next.js or Remix is a really powerful way to build some powerful apps. You also have SQL Alchemy for Python, Doctrine for PHP. So there's a bunch more for every language. Just something you want to think about as a back-end or full stack developer. All right, so understanding and building REST APIs is something that you should learn early on as a back-end or full stack developer. REST APIs conform to the REST architectural style and allow the interaction of RESTful services. And REST stands for Representational State Transfer. And we typically make HTTP requests to work with data or resources, typically stored in a database like blog posts, users, events, whatever. And then from your application or from some kind of HTTP client, you would make a request to that API. This is typically how you would structure your REST API endpoints. So this is something that you definitely need to understand as a back-end or full stack developer, or even as a front-end developer, because you're making the request from the front end. All right, so GraphQL is something that both front-end and back-end developers can use. It's a data query and manipulation language for APIs. So you create a GraphQL server on the back end to work with existing data. And it can be used with multiple languages. It's just really popular in the JavaScript, Node.js world. I will say that, in my own opinion, GraphQL isn't seeming to really take off the way that many people thought it would. I'm not saying it's not popular and don't use it, but there was a point where developers were talking like REST APIs were going to go extinct and this was going to take over. But anyway, it's used in a similar way to a REST API, but it does have some advantages. So you can request specific data from a single endpoint rather than getting all of it like you would with a REST API. You have much more control as to what you get back. GraphQL is strongly typed and has strict document requirements. REST APIs can be kind of tough to maintain if your data is constantly changing. GraphQL can adapt to those changes, so there are some benefits. And then Apollo is a GraphQL client that you can use to request data. There's all types of packages and different clients you can use with GraphQL. Apollo just seems to be the most popular. All right, so authentication is the process of identifying an individual in a web app or any kind of app, and authorization pertains to the permissions that individual has. So that's the difference between authentication and authorization. And as a web developer, you need to really understand how to implement both of these. And there's a few different ways you can do it. So JSON Web Tokens is a popular way to do this with single page applications. So basically you have your SPA, and then you have your backend, and the user validates their username or email and password. They send a request to the server, and then that's validated, and then a token is signed on the server side and sent back to the client. And then that token needs to be saved in the front end, and then it needs to be sent along with any other requests to access protected routes on the server. So that's JSON Web Tokens. And I have a complete video on that and most of this stuff. So cookies and sessions are also commonly used. Just like with tokens, the user data is validated, and if it's successful, the server will create a session, and typically in the database, and include a set cookie header on the response, which will have a unique session ID in the cookie object, so you can validate that way. OAuth is another popular way to validate users. It can be a bit easier to set up. It's a standard for access delegation. So basically what you can do is use your Twitter or Facebook or Google or GitHub account. You can use those to log in to other applications. All right, so it delegates that authentication. You also deal with authentication libraries to kind of help you out. So things like Passport.js. That's something that I've used a lot in the past with Node.js. And then password hashing is something that you'll need to be familiar with. There's different packages like bcrypt to help you do this. Protecting endpoints and routes in your API. So like I said, with JSON Web Tokens, you send a token, and that allows you to access your protected routes. Without that token, a person shouldn't be able to access that protected route. So that's something you're going to have to keep in mind when you're creating APIs. All right, so this next one might make some people make some funny faces, but WordPress is still really popular. It's still widely used. It's a complete content management system built on PHP, and it does have some criticisms, but I think a lot of those criticisms are from people that work at large companies on large teams. It's not from the people that have had to build something substantial in 2 weeks and make their clients happy. So WordPress is still widely used in the freelancing world, or even like a small firm that works with small businesses. And it's been a while since I freelanced, but my clients loved WordPress. I know that the friends that I have now that are freelancers, a lot of them still use WordPress. So I think it's worth mentioning here. And it's also worth mentioning that WordPress can be used as a headless CMS. So you can have your admin area, your back end of WordPress for your clients, and you can build the complete front end with whatever you want. If you want to use Svelte or Vue or React or whatever it is, you can do that. You can have WordPress just spit out a JSON API. All right, so deploying front-end projects is fairly simple. We have platforms like Netlify and Vercel make things super easy. We can even create serverless functions and so on. When we're talking about a full-blown, full-stack application, hosting gets a bit more complex. So you might have to use a different type of platform. So let's look at some of these. AWS, or Amazon Web Services, is really, really popular, especially for really big, in-depth applications like enterprise-level apps. AWS is very popular. I think that it can be a bit overkill for some projects, and it's not something that I've used extensively. The interface is very, very complicated. You need to know exactly which service you're using and where to go to use it, and it can be a little tricky. Heroku is a platform that I like because it's relatively easy to use, and you don't have to set up everything from scratch. You simply push your code using Git, and it runs on something called a dyno. So you can host Node.js apps, Python, Ruby, and a bunch of other languages. And there's an ecosystem of plugins as well. So I really like Heroku. DigitalOcean offers cloud servers called Droplets. These are basically Linux servers that you can install whatever you want on. You can even choose which version of Linux, which distro. So this does take some knowledge in Linux and, of course, using the terminal. There are other companies that offer similar services to DigitalOcean, such as Linode, which is another great company that I've worked with. But yeah, so this is a good option, and you can literally deploy anything that you want. And if you do use something like DigitalOcean or Linode, you're going to need to know how to set up some things like a web server. And two popular web servers are Apache and Nginx. I personally prefer Nginx. I think it's easier to work with. And then containers and virtualization are also very popular, especially in the big business world. And people that plan on getting into DevOps, developer operations, should really learn things like Docker. So Docker is a really popular container software. Docker uses operating system level virtualization to deliver software packages called containers. And containers are isolated from one another, and they bundle their own software, including operating systems, web servers, databases, and more. So you can install anything in a Docker container, and it runs as its own process on your machine. And this is really helpful for teams that work in different environments, because the container has the same software and the same versions. So it'll run the same on essentially any machine, whether it's Windows, Mac, Linux, no matter what version, anything. So Kubernetes is a container orchestration system for automating development, scaling, and management. It's popular to use Docker and Kubernetes together. And unless you're in DevOps, I really don't think it's mandatory for you to learn this stuff. It is very powerful and can be very useful for large teams, but I don't think it's essential for web developers. All right, so when it comes to image and video upload, there are a lot of services that you can use. One of my favorites is Cloudinary, which doesn't just store your images, but it also optimizes them and gives you an API with different image sizes and so on. And it can be used with just about anything. Many front-end developers use this type of service as well. And then Amazon S3 is a storage service. It's actually part of AWS. It's one of many parts, and it provides object storage through a web interface or web service interface, and is extremely scalable as well. All right, so here's some things that you'll need to be able to do to be a back-end or full-stack web developer. So you should be very comfortable with some kind of programming language now that runs on the server. We talked about 9 or 10 of them, so it's up to you on what you want to use. You should be pretty fluent with SQL and some kind of database. I guess if you're not using a relational database, SQL isn't mandatory, but you should know a database and its ecosystem, including tools to connect, as well as any ORMs or ODMs. As a backend or full stack developer, you should definitely know how to create REST APIs from the ground up, including authentication and protecting your routes. You should also be very familiar with the terminal and understand basic Unix commands. You should know how to navigate your system as well as log into remote servers. You should also know how to deploy applications and APIs to some kind of platform. Of course, you don't have to master them all, just have some kind of process you're familiar with. And of course, if you're a full stack dev, you should be able to do this as well as creating user interfaces and the stuff we talked about earlier. All right, so let's talk about some things that kind of go beyond the scope of just basic web development. So mobile app development can be done in quite a few ways with different technologies. You can build native iOS apps by learning Swift or Objective-C. You can build native Android with Kotlin or Java. However, there are some web-friendly tools that you can use to build cross-platform apps. So React Native is a framework that uses React to build apps for iOS and Android, among other platforms, and it has native capabilities. So if you're already a React developer, this is probably going to be your choice, and that's why it's my choice. It uses React, and it uses the React Native bridge, which invokes the native APIs for iOS and Android. All right, now Flutter is a very popular mobile app framework by Google that is used to compile native apps, and Flutter actually uses the Dart programming language, which is pretty similar to JavaScript. A lot of web developers are very comfortable with Flutter. Flutter is extremely fast. It's actually faster than React Native because React Native leverages JavaScript to connect to native components via the bridge, and Flutter doesn't need that bridge, which makes it faster. And Flutter does have great documentation as well. So Ionic is a hybrid framework that is great for progressive web apps or web apps optimized for mobile devices. It's a little slower than the previous two, but you're also not bound to any single framework. If you want to use Angular or Vue or vanilla JavaScript, you can with Ionic. And then I wanted to include Xamarin here as well, which isn't something that I've used, but it's a framework for building mobile apps with C# and .NET. So it's high performance, cross-platform, and if you're a C# developer, this is probably something you're going to want to look into. All right, so what would a 2022 guide be without talking about Web 3? So I think Web 3 is going to be huge. However, I do think that there's a little bit too much hype about it right now. If you go on Twitter, if you're on tech Twitter, it's literally like every other post. So with that said, it's a good idea to get a leg up on new technologies. My goal here isn't to explain in depth what Web 3 is. I don't have the potential to do that. I'm not a master of Web 3, but I do want to just give a brief overview so you have at least some idea and you know what you have to start learning to just get your foot in the door. So real quick explanation, Web 1.0 was basically the informational web. We went to websites and it was mostly just read-only content, right? And then Web 2.0 is the interactive web where the public creates content. However, everything is centralized, whether you're on Twitter, Amazon, whatever the website is, all the data and the control is all centralized. Web 3 is about decentralized apps or dApps that run on the blockchain. Now, the blockchain is a little bit difficult to understand when you're first getting into this. So it's basically a decentralized, distributed public ledger that is immutable, meaning that it can't be changed. So you can actually picture a chain of blocks containing data, and each block in the chain contains a number of transactions, and every time that there's a new transaction, it gets added to the ledger, and each transaction points to the transaction before it, so nobody can go in and change the data. And it's completely decentralized, and unlike centralized servers that can go down, blockchain runs on thousands of nodes. So, I mean, that's a benefit right there, is just reliability. And the first major use of blockchain technology was Bitcoin, which is a form of cryptocurrency. So it's essentially a digital asset. So blockchain is a huge part of Web 3. Now, Ethereum came out a few years ago and is extremely popular because in addition to just being a digital asset, like Bitcoin and maintaining a decentralized payment network, it's also used for storing code that can be used to power highly secure and transparent decentralized contracts and applications. So smart contracts are the fundamental building blocks of Ethereum applications. So if you want to start getting into Web 3 and blockchain, starting to learn how to create Ethereum smart contracts is definitely a way that you want to go. Now, one of the ways you get into creating Ethereum smart contracts is by learning Solidity. So Solidity is a statically typed programming language that was actually designed to develop smart contracts that run on what's called the Ethereum virtual machine, or the EVM. And Solidity is a pretty high-level language, and if you already know JavaScript or Python, you should be able to pick it up pretty quickly. All right, so if you want to get into Web 3, you want to learn about blockchain, Ethereum, smart contracts, and Solidity. And I should also mention NFTs, or non-fungible tokens. This is a pretty big craze on Twitter and other online spaces. These are basically just one-of-a-kind digital assets that are stored on the blockchain. So they can be verified and they can't be reproduced or copied. And the NFT could be artwork, music, or anything else, any kind of digital asset. So that will be another part of Web 3. What I don't like is that there does seem to be a lot of scamming going on in the crypto and NFT world. There's all kinds of pump and dump schemes, and hopefully we can really get that under control. But I do expect at one point Web 3 is going to be huge in the future. Right now it's a little like the Wild West, but yeah, I think it will be big, and it's beneficial to start learning about it now. All right, so WebAssembly is another powerful technology that I think we'll see more of in 2022. It's a low-level assembly language for the web, so its purpose is to create really high-performance web applications. And you can write these programs in very fast languages like Rust. So Rust is very popular when it comes to WebAssembly. You can also use C and C++. And then it compiles down to WebAssembly to run in the browser. And this allows us to create web apps that are much more performant than JavaScript, or what JavaScript can give us. For instance, programs that are CPU heavy. If you're a JavaScript developer, there's also a language called AssemblyScript that is a variant of TypeScript that you can use to compile to WebAssembly or WASM. I should also mention that WebAssembly is not a replacement for JavaScript. It's made to work alongside it. So I think machine learning and artificial intelligence, they have a role in web development, a pretty big role. We saw GitHub Copilot in 2021, and I use it all the time, and it still amazes me how well it works. I know a lot of people think that it's going to take our jobs or whatever, but I don't think that's going to happen for a long time. But the suggestions that Copilot gives me, it's just incredible of what it can come up with. And it really does help me. So, I mean, some things I have to change around or whatever, but I've actually learned from GitHub Copilot. So I think we'll be seeing a lot of AI when it comes to tools that we use as programmers, things that are going to help us. I also think that it's going to be big in testing and tools for testing. There's also machine learning APIs. Amazon has a variety of machine learning solutions. You have Translate, Poly, and so on. We'll see AI being used in things like chatbots, spam filters, product suggestions on websites. Machine learning is also heavily used in user engagement and analytics. So I think it's something that we're going to continue to see progress. All right, guys, so I apologize that this video was so friggin' long. I really tried to cut it down. I just wanted to speak on each topic and not just show you a bunch of slides. So I really hope you enjoyed it and learned from it. So again, thank you so much for watching, and I will see you next time.